So it just dawned on me that I hadn't been recording up until now. So I just started recording on my computer so I could record this lecture. As a brief recap, all that we've talked about is a basic intro to HTML and CSS, and now we're discussing ways to implement CSS into a web page. Some CSS tricks are using gradients. For example, here we have a linear gradient at 90 degrees, and we specify at the 0th position, at 0%, we have this color, while at 35% of our element, we have this color, and at 100% of our element, we have this color. So you can think of it as different gradient stops. For example, we have a gradient here on the background of our presentation. The black would be at the 0th percent, 35th percent would be right here, kind of after the logo, and then the 100th percent would be at the end. Other CSS tricks are using pseudo classes like hover, and pseudo classes start with colons, and they usually follow the tag name or the ID or class name that we are using to identify our element with. And essentially what this says is when you hover over any button element, change the background color to red. So this allows us to have some dynamic styles. Using transform is really great because it allows us to scale, rotate, or translate our elements, so moving them or changing the size. And these are great in conjunction with our pseudo classes because we can say when you hover over this button, scale the button size by 1.2. So that will scale the button size by 120%, making it just a little bit bigger when we hover over it to add some dynamicism. In addition to that, we have transitions, which animate property changes. So here we have a transition for height of 0.3 seconds. So anytime we change the height of our element, whether we're changing it with, say, a hover property like this, a hover pseudo class like this, or with JavaScript, it'll go ahead and animate that change with a 0.3 second time frame. In addition, speaking of animations, we can actually program animations into our CSS with keyframes. What this keyframe says is that it creates an animation called bounce, and at the beginning of the bounce, which is 0%, it will translate our y-axis at 0, so we're not moving our y-axis at all. At 50%, we'll translate up by 20 pixels, and then at 100%, we'll return back to 0. So this little animation is then taken and defined using the animation property here. And what we're saying is run our bounce animation for 0.5 seconds and do that once. And this will occur when our web page loads, when our div loads, versus if we added like the hover pseudo class, when we hovered, our animation would occur. So I'm trying to speed through this just so we can get to the React portion of our lecture and then talk with our teams. But we are going to now introduce JavaScript. JavaScript is versatile and a high-level programming language, meaning that it is easier to program and it's farther away from machine code. Typically, high-level programming languages are interpreted instead of compiled. JavaScript runs in the browser and can respond to user actions, manipulate the DOM, which is the document object model. So that is the structure of our website, the page structure. And it can communicate with the servers. Originally, it was developed for front-end language, but now it's used on both client and server-side programming. So some JavaScript syntax is creating variables. Here are some examples of variables. I'm going to graze over this. Basically, what I want to distinguish is the let keyword versus the variable keyword versus the constant keyword. So this is something I didn't know until I was making this presentation, so I think it might be helpful for you all to know. Essentially, let variable is declared with the variable keyword, and it's accessible and mutable with either function scope or global scope. That means that if a variable is defined in a function, it can only be used inside of that function. However, if it's defined outside of a function, it can be used globally. And we're going to real quick go over what a function is, but that's the basic idea, is that function is reusable code. If we define a variable inside of that reusable code area, then it will be exclusive to that reusable code area. If we don't define it in a function, then it will be used globally. Variables can be legally accessed before they are defined. So if we say we try to access shape 2 here at the very beginning of our code before we've stated it as a variable, we will still be able to access it. It's just it'll show up as undefined. So we'll get undefined if we try to do anything with it. Meanwhile, the let keyword is accessible and mutable with block scope. That means that the let keyword can only be used within the closest block that it's defined in. So if we have nested loops or functions, etc., it's only accessible within the same level of the loop or block or function. So if that's global scope, it could be used only within the global scope area, and it can't be used within functions. However, if you state it in a function, it can only be used in that function. If you have a function inside of that function, it can only be used in the function that it's defined in, not the sub-function. Let variables declared with let are mutable. However, they cannot be accessed before they are defined. So if we try to access shape 1 up here before we state that it's equal to circle, and we state it here, we'll get an error. Constants are essentially similar to let, however, they are immutable. What that means is that although they're accessible within block scope, once you define it and give it a value, like here we're defining a constant called pi, we're giving it the value 3.1459, afterwards you can't change what that value is. So that's how constants work. There are other JavaScript data types, or there are different JavaScript data types. There are strings, which are text, numbers, which are numbers, booleans, which are true false values. True false is given with an lowercase true or false without quotation marks. Quotation marks make it a string. Objects, which are key value pairs, where we have our keys with our values, and those can be referenced outside of, you can basically store multiple kinds of data with them. Arrays, which can store multiple data as well, and then null, which is its own data type, which means there is nothing here. If you want to learn more about JavaScript, I can provide resources. Please let me know. But these are all really basic concepts, so I'm running through it really fast. Functions allow code reuse and modular design. So for example, here is a function with reusable code. What this function will do is it takes an argument, which is a name, and then it will print, or it'll use console.log to print hello plus name. So we can give it any name. When we call it, this is a function call here, where we are calling our greet function with our argument Jake. So Jake will go into that name variable and then be used here when we're printing out hello plus Jake. Meanwhile, here we're using it with Alice, so it'll print out hello Alice. So Alice will go into that name argument, and then that name argument will be used in our code. We also have control flow with conditionals. For example, here is an if statement, which checks if the age variable is greater than 18, and else it'll default to minor if it's not. Conditionals are with if, else, and else if. Meanwhile, you have loops, which loops are for repeating the internal code until the condition is met. So here we have a condition where we are creating a variable called I, and while I is less than 5, we are incrementing I. So we are adding 1 to I. That's what the plus plus means. That means that we're going to start with 0. We're going to print 0 using console.log onto the console. Then we're going to log 1 because we're going to increase I. We're going to increment I. We're going to increment I again because I is still less than 5. And while it's less than 5, we're going to continue to increment and print out our I. So when I finally becomes 5 after we've incremented that last time, we're going to stop because I is no longer less than 5, it's equal to 5. So the DOM is the document object model. It's the structured representation of all the HTML elements. And we can manipulate this using JavaScript. So JavaScript can actually interact with our web page and edit the elements in it with these by selecting our elements using document.getElement by, and then we provide either the ID or class name, etc. In addition to that, we can change like our text content in this example. So I can actually show you all a live example real quick. If I take, for example, the Hispanic Hackers website here, what I can do, I'm going to open up my web inspector like this. I'm going to go into the console and I'm going to say, let's see, I'm going to come into here and I want to see, this is our H1, this is our class. We can give this an ID real quick. ID is equal to heading. So now we have an ID of heading here. What we can do is we can say document.getElement by ID, and we're providing our name, which is heading. And what it does is it returns this H1, which, as you can see, highlights when I hover over it. Then we can go ahead and do, we can say document.getElement by ID heading like this. Oops, doesn't want me to paste. Document.getElement by ID of heading, and then we can change our text content, and we can say this is equal to test, like that, and you can see our heading changes to test. So we can actually manipulate our JavaScript using the web inspector. This doesn't manipulate it for everything, for everybody's website, just for my web page. But when you're uploading JavaScript code onto your web page, you can also create interactions which will change the way that the web page is structured. And so you can also add event listeners. Event listeners will basically check for certain actions. For example, this event listener is checking if the title, which is here, our element with the title ID, if it is clicked, then we're going to alert button is clicked. So this waits and checks for if a user clicks on that element. There are other event listeners like mouse over, which checks whether or not we've hovered over it. There's a lot. There's like scroll event listeners, there is page size changing event listeners, and they basically allow us to interact with the web page. So this is what I really wanted to get to because I feel like this is novel, not novel, but this is important information when you're looking at how web pages and browsers work. So the last time we talked about web pages, we talked about web design and development, and what we went through is how websites are returned and retrieved from servers. And so this diagram shows you what happens after the code has been retrieved. So our code has been retrieved, and what happens is we have our browser. This gray box is our browser. For example, Chrome or Firefox or Safari. And our browser takes our code, and first what it does is it takes our HTML code and it parses it. And it converts our HTML structure into a document object model, which is an object related to our HTML code. It will then parse our CSS, which is our styles, and create the CSS object model, which is another object created from our CSS styles. What it'll do then is it'll combine our document object model and our CSS object model into a render tree. And what that does is it gets rid of hidden elements. So if we have any elements that say that they're hidden in our document, even if it's temporarily, it will delete them from our render tree. It gets rid of metadata and head content, which isn't important to actually showing the web page on our computer. And it gets rid of unnecessary data. It also combines our CSS styles, and it determines what the true version of our web page is and what it looks like, even if you have multiple CSS styles stacked on top of each other. Then it'll go through a process called rasterization, which turns our element into pixels and layers, and then composition, which combines those layers into what our website should look like. Then we use interpretation to trigger machine code to generate the pixels that show up on your screen. This is similar to how a lot of applications actually show up. Meanwhile, our JavaScript kind of goes through a different process. Most browsers have a JavaScript engine, which contains a JavaScript interpreter and a JIT JavaScript. This can be broken down into a different word, but a compiler. What JavaScript does is it will interpret the code that we've written, and then it'll take that interpreted code and it'll compile it into machine code. And then that machine code will go ahead and edit the pixels that we see on the web page. So the JavaScript engine interacts with the render tree in our browser, but it will go ahead and edit our render tree and the ultimate output onto our machine. So that is essentially the process that websites go through to take our code. That's what the browser goes through to take our code and translate it into machine code and pixels. And that wraps up our talk about web programming languages. Next, we're talking about web frameworks. So web frameworks are an abstraction of programming languages, which provides code as libraries and references. So it provides you code that's kind of nitty-gritty that we don't want to program ourselves, and it gives you a lot of tools for structuring your web pages, APIs, etc. So what is a framework? A framework is a pre-built set of tools, libraries, and best practices that provide a foundation for developing software applications. It defines a structure for developers to follow and streamlines the development process. So that's why we use frameworks. Back before frameworks existed, we would just program everything nitty-gritty using HTML, CSS, and JavaScript. Sometimes we'd use PHP for server-side code. However, now that we have frameworks, our frameworks give us tools and resources to simplify our coding process, and so that we don't have to define it all ourselves. The purpose is to enhance productivity, SEO, and provide reusable code such as components, consistency, and allowing developers to focus on building features rather than copying and pasting and sorting everything out from scratch. So what is a web framework? A web framework is a specialized framework designed specifically for building web applications. It provides an environment to develop web servers, APIs, and client-side interfaces. The key features are routing, which is how you manage your different pages and paths on your web page. Middleware, which is the process that it uses to accept incoming requests to the server and return the right responses. Template engines for facilitating rendering, combining static and dynamic components, and then database integration. Not all web frameworks have all of these features, but most of them do. So one thing I wanted to mention, this is the same graphic that I showed last week about how web pages are returned from the server. Essentially, your computer will contact your internet service provider's network through your at-home or at-business internet router, and then that will then go through a bunch of fiber optic cables as a network and find the domain name server, which is somewhere in some data center. And then from there, it will go and find the host server using the location pointed to by the domain name. And then it'll go ahead and return all of that code or all of that data through the same channel. So This now brings up a great distinction to mention, and this is something we'll go into more when we're talking about different kinds of applications, but there's a difference between front end and back end. Front end is used to show the interface for a application, while the back end does all of the logic behind the application. Now, front end is responsible for UI components, so that user interface, like buttons, forms, modals, etc. It's also important to manage the state of the current website image that you're seeing, routing, so the page navigation, and responsive design, so responding to different screen sizes. Some example of front-end frameworks are React.js, Angular, and Vue.js. Back-end frameworks, on the other hand, are tools and libraries that facilitate the development of server-side applications. So they handle business logic, data processing, and communication with databases and external services. The important thing about back-end frameworks is that they tend to hide all of the logic needed to take customer information and database content, etc., behind a wall that you can only access using the proper API key and routes. So you really have to know how the backend is set up and have the appropriate code in store to access the backend in order to access the right data. So what it really does is it provides a layer of authentication and authorization, middleware management for processing requests and logging, and API development. It also allows for database interaction. You don't want to include things like user login, authentication, and database interaction in your front end, and the reason why is that the front end can be accessed, for example, with our web inspector here. So in this web inspector, I can access and change and use all of the front end code. However, what this web inspector doesn't give me direct access to is the back end code. And so keeping a distinction between front end and back end is important, because if you had your database included in your front end, I could probably query your database here and retrieve user information that should otherwise remain private. That's why having a back end is important. Now, some back end frameworks are Express.js or Node.js, which is built off of Express.js. Django, or Express.js is built with Node.js. Django, which is built with Python. Node.js is a JavaScript runtime, and Express.js uses JavaScript. So before we jump into developing with React.js, I just wanted to show y'all some distinctions between frameworks, web frameworks specifically. So if I go to drebarrera.com, this is my personal web page, my personal portfolio, and I've created a link for people who are starting up startup projects or just projects in general. This gives a plethora of information for creating a business, but tech business, but also how to choose your web application structure. And I plan to add more information about this soon. However, for the time being, what I want to show you are the distinctions of using a web framework. So web frameworks provide a lot of modularity, but there are a lot of different web frameworks. Here we're comparing a couple different ones. Here we're comparing Next.js, which is an abstraction from React.js, React.js, Vue.js, Angular.js, and Express.js. And as you can see, this shows you the popularity of each one in their search. Right now, Next.js is the most popular, and it just became uber popular in 2022, but this was also when Google underwent a change to their platform. That's why there's this note here. Meanwhile, React.js is the next most popular, followed by Vue.js, Angular, and then Express.js. If we scroll down, this shows you some information about the networks, or the frameworks. So Next.js provides out-of-the-box production features, server-side rendering, faster initial loads, static site generation support, and a lot of other features. It's built off of React.js, so it includes almost all of the React.js features, and then some, and that's why it's so popular. Meanwhile, React.js, which is the second most popular web framework, is very efficient because it uses component-based development, a virtual document object model, so it has an actual server-side document object model, which then gets sent to the browser. And so that is used to basically provide efficiency and change only things on the server side before publishing them to the browser. That really results in a lot of efficiencies that React.js and the server can control. There's a large active community support, abundant libraries and tools, quick development features. All of this is why React.js is one of the most popular frameworks today. Some of the downsides is a steep learning curve, complex state management, which we'll actually talk about next week, JSX syntax unfamiliarity, and other issues. And then in terms of other popular frameworks, we have Vue.js and AngularJS. Vue.js stands out because it's very simple and easy to learn. It has high scalability and active community support. Angular is a little bit older, but it's mature as a result, and it can be used in a lot of different ways. I've seen Angular used most frequently for like dashboards and more robust architecture and features. So this is a really great resource. I will actually go ahead and put this in the comments. And here we go. This is the link for the startups site. And I'm actually going to move this to the Circle Square Labs website soon. Josh says to check out roadmap.sh, and I'll have to check that out later. But this basically gives you a comparison of some different web frameworks and just frameworks in general. What it doesn't do, and something that I want to implement in the future, is provide a distinction between back-end and front-end frameworks, because Express.js is used as a back-end framework, while React.js is typically a front-end framework. You don't really see it used at all as a back-end framework. Some honorable mentions are Spring Boot, which is a Java, and Java is a separate language from JavaScript framework. Spring Boot is used very robustly, but I'm not a big fan. I kind of hate it. Ruby on Rails is a very popular one these days. A lot of people love Ruby, but if you love Ruby, you use exclusively Ruby usually. And people who don't know Ruby, just there's a steeper learning curve because it's a different programming language altogether. So a lot of people swear by it, but a lot of people just don't bother to learn it. Django is another popular framework, and that one uses Python. However, Python is not a JavaScript language, so it has to interact with the browser differently, similarly to Ruby, Java, and PHP here. So as a result, you have a different kind of angle to website development. And so there's more information here, especially on hosting websites. We'll get onto that later. But back to developing with React.js. So actually what I'm going to do here is I'm going to pause for 5 minutes so that everybody can have a water and bathroom break. So we are going to resume at 8:05. I will see y'all then. Okay, we're gonna get started again. Some really great resources have been posted in the chat, so I highly recommend everybody checking those out. Um, I haven't checked out Full Stack yet, but I did check out roadmap.sh just a second ago, and it's great for kind of giving you a planned roadmap on how to learn different parts of a programming language or framework. And I'm sure that there are more features. I just glanced over it. But we are going to resume talking about developing with React.js, which is the intention of this meeting. Our goal here is to learn more about how to develop with React.js and introduce it to people who aren't already familiar. So what is React.js? React.js is a popular open source JavaScript library and framework used for building UI or single-paged applications. So one thing is React.js is intended to build single-page applications. However, the React router library allows you to expand that and create other routes. So that is one thing that I want to capitalize on, and we'll talk more about this later. So we can technically build multi-page applications with React. Now, some key features are component-based architecture, virtual document object model. So we talked about how the document object model is contained on the server side and then published to the browser so that there's a minimization of direct manipulation of the actual document object model on the browser side, and there's more adjustability and modification on the server side. In addition to that, React.js features unidirectional data flow for predictable state management. So our data moves from higher level components to lower level components. And again, this has to do with our component-based architecture. So some key concepts of React.js are building blocks which are functional or class-based. So our building blocks are our components, and you can either make them out of functions or you can make them out of JavaScript classes. Each component has its own state management and renders UI based off of properties that are received from parents or more high-level components. JSX is JavaScript XML. It's a specific syntax feature that React.js uses in order to make code more readable and easier to write. And in addition to that, React.js provides state management, so being able to manage the content on a web page. So this has a lot to do with changing dynamic content. So for example, say you have a piece of data that you're displaying on your website. For example, the temperature outside. That temperature outside is going to come from an external API, and we have to basically manage how we take that data, how often we take that data from the API, and how we manage it onto the actual web page and display it. And so that is called state. State is our dynamic data that changes over time. We also have props, which are properties and data, or which is data that we pass from higher level components to more lower level components. So this is an example of a React component. What we are doing is we are importing our use state from the React library. We are exporting as a default our component, which our component name is counter. And whenever you're creating a component, you always want to export as a default the main component in your file. So in this case, the main component in our file is going to be our counter. Our counter is taking our props, which is the properties or the data passed to it. And then inside of our component, what we're doing is we're using our state to create a state variable called count. We're creating an optional function, which we can use. It's not optional, but we're creating a function here called setCount, and the setCount function can be used to change the state. And then we're giving the initial state of our count 0. So initially our count is at 0 because we've specified it here. We have a function called setCount, so we can change that, and then we can reference the current count by using this count variable here. Now we're also providing an internal function called increment, which will increment our count value by setting our count equal to the current count plus 1. Then we're also returning the UI part of our element, which is how our element, our component actually looks. And our component, we are returning this HTML content. So some important things to note is that a component should always be exported if you're going to use it in other code. So because we use modular or component-based code, we typically have a file dedicated to each one of our components. So this would be a single file. And what we would do is we would import this file and our component counter from this file into another file. And so what we want to do is we want to export our component counter in this file so that we can import it into another file. So we're exporting our counter. Here we're using state, and we'll talk more about state in our next lecture, but we are creating a state component, a state portion, which would state variable called count. And then here we're using our count and we're displaying our count in our actual return content. So in our actual UI, we're displaying our count. Up here, we're displaying our title, and our title is coming from our props. So what props is doing is it's passing down data from higher level components. So the parent component, which has the counter inside of it, will pass down the title. So we'll specify the title in the parent component. And then we have a button here. When we click our button, we are running the increment function, which will increment our count and change our state. And then that change of state will be reflected here in our second heading, which is showing our real-time count. Here we have some style. Our styles are given in object format instead of our typical CSS styles that we see in normal HTML documents. So this kind of document is called a JSX document, and these JSX documents take on a different format than normal JavaScript or HTML components and documents. So in our main app component, what we would do is we would import the counter. And so this would be importing our counter component from the counter file. And then here we use our counter component and we give it a title of simple counter app. What this title will do is it sends this string to our props variable as title, and then we use it here in our first heading. So that's why we give this attribute title. This attribute becomes an attribute that's mentioned in props. So that's very helpful. And then the main app component basically serves as the entry point for the React application. So this would be the top level component in our application. Now there are two different types of components. There are class components. Class components essentially hold and manage local state. They have access to lifecycle methods, which are these different methods or functions that you can use to determine different states of the component in the browser. And then they're typically used for more complex components. And they have a lot more of a complexity when you're defining them. Meanwhile, functional components are like the ones that we've seen here, where they use functions to create the component. Functional components are simpler and easier to read. They utilize hooks for managing state, like useState is a hook. And they are typically more ideal for presentational components or simpler logic. So this is really important and really you can see either one when you're looking at a React app. A lot of times people use class components for more robust features versus functional components for more simple websites and web apps. So if you're building like a company website, I would recommend using functional components. However, if you're building like a dashboard or a more complex app, I would recommend class components. So I had mentioned routing. Routing is basically how we access different pages in our website. In a typical website, our pages are based off of the HTML files in our web page, but with our React web page, we are using only JavaScript files. So we have to use a React router to determine which JavaScript items are being shown on our website. Now, as I had mentioned, React is typically used for single page applications. But these days, we use the React router to create multi-page applications by specifying which components show up when. So the React router basically provides dynamic routing, nested routes, and browser and hash routing to improve user experience. This is an example of how routing would look, and this is inside of our app component. Our main app component has the browser router item, which comes from our React router DOM library. And inside of that, we specify our routes. So if we're just doing a normal search to our domain, you're going to get just the basic index page, which is our home element here. Inside of that, in addition to that, we have an about page, which shows the about element or component, and then we have the contact page, which shows the contact component. So what this router element does is that this router element determines which components are shown based off of which path we're giving our URL, which URL we're using. So there are a couple different ways to structure our React.js project, but the main way that we typically structure our React.js project is by creating in our app folder a public and source directory. The public directory basically contains some of our public information that can be directly accessed from our application, versus the source directory contains our assets, our components, our containers, our hooks, which are custom hooks like set state or like React state, our pages. So this would be page components, which are routed to in our app, which is our main app component. Our services, which go ahead and query our APIs or external services. Styles, which provide our CSS. Utils, which are utilities, and those are typically JavaScript files that provide functions that can be used for processing and, for example, maybe changing over website images to WebP files or other processes. Our app.js is our main application component, and it's the entry point into our application. Our index.js is our entry point for the whole React app and renders the app component, which is app.js. And then routes.js, if using React router, a lot of times gives configuration preferences for our application routes. These are some other standard files that come with building a React app, because React is based off of Node.js. So Node.js includes a package.json and maybe some other files, like package lock.json. Package lock.json is actually pretty important. So if you want to know more, you should look that up, and we might explain that more in future lessons. So some best practices when using React.js is taking advantage of the component structure. That means organizing your components into reusable modules. So what we're doing here is we're organizing we have our index.js, which loads our app.js main application component. Our main application component will use the routes in our routes.js to load our page components in our pages directory. And then each one of our page components will access components in our components directory, which has our forms, our layouts, etc. In addition to that, we have like container components, which are used if you're using state management, and other directories for organizing the structure of our web page. Using state management and state management libraries like Redux for managing global state across the application is important. We'll talk more about this in the next lecture. Performance optimization can be done with React Memo and Use Memo. We'll go over this again in next lecture, as well as code splitting using React.lazy and suspense. So our next lecture is going to be over advanced React.js techniques, and that will be discussing concepts like these for optimizing our web pages. Now, the last portion of our lecture before we talk about our teams and get a team status update is developing with Next.js. Now, Next.js is based off of our React framework, and what it does is it includes additional features such as static site generation and server-side rendering. Why use Next.js? What Next.js does is it enhances SEO performance and page load speeds. It also simplifies routing, deployment, and optimization. So what Next.js does is it helps abstract React.js so that you can have a multi-page application, such as a standard business website. It's frequently used and popularly used for building fast-loading, scalable websites and applications, as well as e-commerce sites, blogs, etc. That can be benefited by both static and dynamic content. So Next.js does a really good job at taking the dynamic functions and abilities of React and then turning it into an efficient application for an efficient system for rendering static websites as well. So this goes largely in part to static site generation, which is a method of pre-rendering web pages at build time to produce static HTML files. The benefit of that is better SEO. So search engines will immediately have access to additional client-side rendering. In addition to that, it will create faster load times and higher performance and provide better scalability for when you have large traffic spikes. That's why static site generation is typically used in more commercial aspects, such as creating websites for like your company website or commercial applications that you'll have users accessing. Using get static props in Next.js is a feature to fetch data at build time and generate these static pages. So we use get static props to basically load in data and then include it in that static file that's sent over at runtime, at build time, after build time actually. So that is important, and we might talk about that more next week. Another feature of Next.js is server-side rendering. Server-side rendering is a method for generating HTML for a web page on the server at request time. So this is how you generate your DOM model, your document object model, on request time, and then turn that into static files. Each page load or route change triggers a refresh. So what this does is this manages how often we refresh and change our document object model and how often we send new versions of the web page to the browser. This results in SEO friendliness because you're not sending constant changes to the browser, and you're sending pre-rendered versions of the server. And then you have enhanced performance from the first load because it sends fully rendered pages on that first initial load. You use get server-side props to fetch data for this level of rendering, and we might talk about that next week as well. So in order to route on Next.js, there are two different kinds of routing. There is page-based routing, which is traditional, and this basically allows us to create new JavaScript pages within our pages directory in the file structure, and we'll show that in a second. We can provide dynamic routing using these brackets. These square brackets give us dynamic parameters, and then we can fetch data using get static props or get server-side props, as well as get static paths for the actual route, the actual path of your, that's the actual URL path, essentially. There's an additional routing method which was introduced in Next.js 13, which is an alternative to page routing. This is using the app router, and the app router provides nested layouts, so it allows you to define nested layouts and components that persist across pages. For example, your header component, say you have that big header bar at the top of your web page, you can statically define that and include it in all of your web pages so it doesn't have to change when you switch pages. In addition to that, you have additional server components, loading states and error handling, and file-based conventions. So these are all features that were introduced semi-recently. It's kind of old now, but app router is typically recommended by Next.js when you're starting a project. I recommend app router when you are creating web apps, versus I recommend page router, page-based routing, when you are creating like static websites like a company website. So this is the file structure for page-based routing. What you have is you have your app folder, and then you have a pages directory, and inside of that directory, you have each of your web pages. So Next.js will go ahead and process this and say, okay, we have an index page, we have an about page, we have a contact page, we have a blog page because we have the index page here, and then we have a set of blogs pages with different IDs. These square brackets allow us to have dynamic routes, so we are able to say blog /1, blog /2, blogs / we could even give it a string, blog title, right? And each one of those will be a separate page with separate data that's referred to by that ID. In addition to that, we can have components. Our components will be referenced in our pages individually. And then here we have our public data, which is data that's brought in and can be referenced publicly via the URL. Down here, we have an example of our dynamic route. So in this case, we will go ahead and get our ID number from our router.query, and then we're updating our heading tag with the ID number. So we're saying blog post ID. So this is how we get data from our URL. We can also then go ahead and use this ID to query a database or query an API and retrieve data based off of this ID that we get from the URL, and then be able to turn up new data based off of the page ID that we give here. So the URL would look like www.websitename.com/blog / our ID number, and that's how we would access it. Meanwhile, app routing works a little bit differently. App routing has an app directory instead of a pages directory, and it uses a layout file. That layout file applies the same layout to all of the pages inside of this directory and subdirectories. Anything with a page.js is a file, a web page, and then when we have about our about directory here, we're creating a new web page which is in our about is the about page, essentially, like this. Um, Here we have, similarly to the last example, we have a dynamic ID for our blogs. So this will go to blog/our ID. And then we have our components and our public data like always. When we're talking about getting our page number or our ID here, we're using params instead of having to use our use router from our next/router library. So it's a little bit simpler to get data from our parameters, from our query parameters in our URL. So our general Next.js project structure, this is showing with page routing, mostly because we are going to be using something similar when we're building websites. So this is a page routing structure, but this is how your Next.js project would typically look. You would have your pages folder. Your pages folder would have a API directory with all of your API routes. So this would be when we are calling different functions and requests in our API, if we have API included in our website. In addition to that, we have an index page, an about page, contact page, our blog page, our ID page. We have a public directory, which has our images and our public resources. We have a components directory, which contains our components. We have a styles directory, which has our CSS. One thing to note is that we have a globals.css, which would be included in all of our web pages. And then we have modular CSS, which is based off of, which can be included in specific components or pages. And this modular CSS gives specific styles which are exclusively used in those components. In addition to that, we would have utility files, and then we'd have our standard Next.js configs and our Node.js config files as well. And so that is about it when it comes to Next.js. The take-home video will go more into how we actually program a Next.js site, but this is a really high-level view of how Next.js is set up and React.js as well. I hope that y'all learned something. Does anybody have any questions? Okay. Doesn't seem like anybody has any questions. If you do, feel free to speak up, unmute, or text me in the group, in the message chat. You can also always message me at hispanichackersboard@gmail.com or here on Discord. But again, the take-home videos will have more information about how to actually apply these different concepts. Now, I want to ask everybody to fill out their attendance. I'm going to give us about a couple minutes, probably 5 minutes to do this. This helps me keep track of who came to the meeting, whether y'all are regular attendees or not. If you're not a regular attendee, when it asks about your project, go ahead and put, like, you're just not a regular attendee and you're not enrolled in the project. If you want to be a regular attendee and have a project, please message me either on Discord or at hispanichackersboard@gmail.com. But go ahead and scan this QR code and fill out your attendance document. This will give me a basis for who showed up today. And then this will also tell me how far y'all have gotten so far in your projects. Following this, we'll go ahead and talk to each of the people who are running projects right now. I want to get an update from y'all. So if you are not a regular attendee of Code Foundry, if you want to become one, feel free to let me know. That would be awesome if you did. However, if you can't make regular sessions, you're welcome to join whenever you want. Our meetings are posted on meetup.com. And then you are free to go if you are not a regular attendee. If you are a regular attendee, please stick around for the chat about our projects. So we'll reconvene after everybody's filled out their attendance. in a couple minutes.
What happened to the Ion channel? I don't have it, or I can't see it anymore.
Okay, that is an important change. So one thing is I'm gonna announce the questions that I get because my screen can't record internal audio, or my recording system. So I think it was Josh asked, or somebody asked. That wasn't Josh. Who was that?
It was me.
Oh, okay, sweet. About the Ion channel and how it's disappeared. I went ahead and made the Ion channel private. I'm going to put the link for the inviting and into access on this chat, and anybody who is a part of the channel or a part of the project can join. However, don't join unless I've told you that you're a part of the project. Now, everybody should have received a email about your project assignment this last week. If you didn't receive one, please let me know.
I did receive the email. I do not know. I was trying to find it to create a group message because not everyone gets notifications from Discord.
Yeah.
So I've talked to like Ruth and then Eduardo, but I haven't heard from the other two individuals, and that email's gone. So
okay.
We forward that to me again?
Yeah, let me see. Let me see who I sent that to. It's in the sent folder. So I had CC'd you. Is your email wjfletch26@gmail.com?
Yeah, that's it.
Okay, it should have gone to you. Check your spam folder. It might be in there.
No, I'm saying I did get it the other day. Oh, like you just now sent it? Oh, there you go.
You found it?
That's cool. You're saying you just sent it to me?
No, it was sent on October 31st, so a couple days ago.
Yeah, no, I looked at that one, but for whatever reason, I must have deleted it or something. I looked in my deleted files as well, and I cannot find it. I mean, maybe what's the subject line?
The subject line is Code Foundry project assignment. I'll go ahead and re-forward it to you. All good. Send. Just forwarded. Okay, so
that's weird.
If we are new, you want us to leave, or Patrick said. Patrick, you're free to go. If you want to become a regular participant, feel free to stay or message me on Discord that you want to become regular and want a project assigned to you. However, you are free to go because that's all we're going to talk about for the rest of the meeting. But it was really great having you here. So feel free to pop in anytime that you want. Okay, so once everybody's filled out that attendance form, essentially I want to get everybody's status on their projects. So the project, people who are leading their own projects, I'll get to you after talking to Josh real quick. Josh, it seems like you tried to reach out this week but didn't have much luck. If you are on the Ion project and received an email about that, go ahead and jump on the link that I just sent on the chat. That is an invitation to getting on the Ion group chat. And then from there, Josh can email you about the project. The goal of last week was to get everybody familiar with their project and set up. So now would be the time to come up with your branding standards and then start your website together. So working on what the web page is going to look like on Figma using the last take-home videos, last week's, and then we're going to start implementing that into Next.js. Our goal is to have that done in 3 weeks. Our in-person meeting where we're going to give updates on that is in 2 weeks. So the week after next is where we want to have a group sync and some presentations to show off of what have y'all done so far during Code Foundry. So go ahead and get familiar with your groups as soon as possible so that you can get that started. Does that sound good, Josh? I want to make sure I explained clearly.
Yeah, that sounds good to me. I wanted to let you know that in the second Figma video you provided, it's just the same link. I'm not sure if it was supposed to be something else, but
probably was.
Yeah, there was that. What was that?
Go ahead. It probably was, but let me check it out.
Okay. And yeah, that's pretty much where we are. We're going to get the team together and talk about
today where
we're at and everything. Go ahead.
Oh no, sorry. I just accidentally opened up the video and it made noise. Okay. Okay. Yes, I will get the updated follow-up video. That one was just more direct on how you actually build an app with Figma, like prototype, versus the other one was all the 101 basics. So if you're already familiar with Figma, go ahead and you can skip the 101 basics and jump into the actual just 17-minute video, which was a short recap. But yeah, okay, sounds great. It sounds like y'all are on track. You just got to get acquainted with the team.
Hey, I'm not really sure why, but when we click the join that channel, it doesn't really show up on our channel section. Not really sure what's going on.
Okay, gotcha. Then in that case, if you are part of the Ion project, message in the chat your username or just message that you're a part of it, because I'm having a hard time connecting the username with the actual like person's name, right? So JS Doza, and then I'm just
gonna put my and I can aggregate everybody into a at I have to do it also off of Discord, so that's where I'm talking with you guys about getting a text message or possibly going somewhere else, because the notifications are coming through for everybody on Discord.
Okay, that makes sense. Josh, are you able to see the Ion chat?
1 second here. Hold on. Taking a look. You sent me the invite. I have not clicked into it yet.
Okay, but you're not able to see it on Discord? The actual channel?
No, wait, yeah, you can see it, yeah.
Okay, you can see it? All right, sweet. I just added the rest of y'all as friends so I can hopefully bring you all in there. But that's weird. That's an invite. I want to not create invite. I want to invite, add permissions. Yes, those are... Okay, who else? I am adding Ruth, and then got you. Sweet. I don't think I have everybody, but I think I've added most people to the channel. Let me just one more person. Okay. If y'all are part of the Ion project and you don't see the Ion channel under Code Foundry Fall 2024, let me know. Okay. So what I am looking for now is I'd like to go ahead and talk to everybody who selected independent projects. Actually, Josh, do you have any other questions for me? Or anybody else on the
just
project?
are we supposed to be able to access the PowerPoints?
The actual presentations are Figma presentations, so they're not PowerPoints, and I haven't provided access to them. I was thinking of providing access to them at the end of the bootcamp, because I want everybody to be taking notes. But the videos are posted online on YouTube, and the last video should have just gone up a couple of days ago. So those are on the resources page.
Awesome. Thank you very much.
Yeah, no problem. If y'all have any questions, feel free to let me know, but I'm going to move on to the people who are doing independent projects. So let's start with, I'm going to look at my attendance here. Where's my attendance? Okay. So the people who are here today, Nicholas. Nicholas, you're working on an independent project?
Yeah, can you hear me?
Yeah, I can hear you.
Yeah, so I've been working on a project like previously, like it's a mobile application, so I wasn't sure if I could do that or just kind of come up with a new project, but...
You're more than welcome. Sorry, go ahead.
No, go ahead.
You're more than welcome to work on your current project. The goal is that everybody in the program gets to build a website, whether it's independently or with a team, branding content, and a mobile app. The mobile framework that we're teaching is React Native. However, if you want to work in a different framework, feel free to. It's just our lectures are going to move towards our React knowledge, channeling that and building actual mobile apps with it as well, other than just web apps. Does that make sense?
Okay. Yeah, I am using React Native, so that works out perfect.
Okay, sweet. So are you going to
I'll send you an email about like the project description and all that.
Okay, sounds good. What is the project name? Do you have one?
Right now it's called FitBet. So it's basically like a fitness app that's also like an accountability. So basically it's like you're betting your friend to reach your workout goals.
Oh yeah, I saw that one. That one was cool. I think you submitted it when you signed up, right?
I might have.
Okay, well that's dope. Let me know. Send me an email with the description and the name.
Okay, I will.
Sounds good. Okay, next person is, let's see, today's date. We've got Hugo. Wait, is this from today? I think this is from the 28th. From today's. Lisa, you're working on an independent project too, right? Lisa messaged, or no? Lisa, are you there? She might have left. Yeah, she left already. Okay, that's fine. Who else do we have? We have Nicolas. We also have Alexander. Are you here still?
Howdy.
Hey, how you doing?
Pretty well, how are you?
Pretty good. What are you working on? What is your idea for your project?
So I haven't gotten a chance to submit it, and I'm still kind of coming up with a name. But basically how it's going to work is I just want to create a browser extension that can essentially use like OpenAI's Whisper technology to just transcribe, or not transcribe, but to actively translate basically like shows, movies on Netflix, on streaming platforms.
Okay, like into English?
Yes.
Oh, that's cool.
Preferably, yeah, because oftentimes, because I'm trying to broaden my language repertoire, and I noticed that a lot of subtitles don't really match up with what the characters are saying in certain dubs or in certain languages. So I figured this would be much more accurate.
Okay. Yeah, no, that's awesome. I've also noticed the same issue. However, given that you're creating a browser extension, I'm guessing you're creating a Chrome extension?
Yes.
Okay, so
although I would prefer to focus on Firefox.
Okay. Well, so you'll be using their extension toolkits, which means that you're going to be using JavaScript, HTML, and CSS natively. You're not going to get to practice so much React, other than maybe building a website and some branding content. Is that what you're looking to do, just to practice what you're learning in class?
Yeah, I mean, getting some React in would be good, but this is mainly the main goal.
Okay.
Yeah.
As long as you're happy with what you're doing and you feel like you can apply what you're learning, that's the main goal of having a project that is associated with the bootcamp, right?
For sure.
Okay, sweet. Again, I would love to see you create some like branding content and a website for it, so you could actually apply what you're learning, and then you could showcase that at our next in-person meeting. But it's totally up to you.
Sure thing.
Okay, sweet. And then the last person who is doing an independent project is Danielle. Are you here, Danielle? Danielle? Possibly not. He may have ducked out. Okay. Well, then in that case, I think we should be good to go for today.
Andreas, this is Jeff.
Are you Daniel?
No, this is Jeff.
Jeff.
We
Okay.
talked at the end of last week.
Yeah. Okay, gotcha. Yeah. How are you doing?
Pretty good. Pretty busy, like everybody else, I'm sure.
Yeah.
Long story short, so I have two ideas. So the hackathon started last weekend, the religious one I told you about.
Yeah.
One group has kind of a cool, they spent some time and built a chatbot to be in a, I didn't realize the term, but they call it like an apologist, to basically tell you why. I think they sucked in they consumed all the literature out there, and then they try to point out the difference between Christianity versus the other religions.
Mm-hmm.
And so they had some side projects like speech to text and text to speech, language translation, maybe some UI help.
Interesting.
To work on that, which sounds pretty interesting. To me, at least. The only issue is the hackathon is 1 week. I could potentially work with them more